All right, everybody, this is it. Schlansky's Guide to 65. All the commonly asked, not hard geometry Regents questions. Let's get right to it. The sides of a triangle. The two smallest sides must add to be greater than the third side. So I go through the choices. Let's take a look at choice one. My two smallest sides would be 3 and 4. Are 3 and 4 more than 5? Yes, 7 is more than 5. Choice 2, my two smallest are 2 and 2. Are 2 and 2 more than 3? Yes. 5 and 7, are 5 and 7 more than 9? Yes. My two smallest, 1 and 4, are 1 and 4 more than 6? No. 1 plus 4 is 5. That's not more than 6. Which one cannot make up the sides of a triangle? Choice 4. Now, this next type of question, it's the same lesson, just asked differently, where they give you two sides and they want to know the third. Well, if 12 and 8 are definitely the sides of the triangle, if choice 1's the answer, that means that the three sides are 17, 12, and 8. 4, 12, and 8. So I'm going to just add on the two sides to each of the choices, and I'm going to do the exact same thing that I just did. The two smallest need to be more than the third. The two smallest in choice 1 are 8 and 12. Is that more than 17? Yes. The two smallest, 4 and 8. Is that more than 12? No, it's equal to 12. It's got to be more. The two smallest, 2 and 8. Are those more than 12? No. The two smallest, 8 and 12. Is that more than 21? No. Which one is a possible value? Choice 1. All right, corresponding parts of congruent triangles. They're going to try and trick you. They're going to take an easy question and make it complicated. Don't let them do it. This picture sucks. I'm going to draw my own picture. I'm going to draw my own two triangles. They don't have to look like the original triangles. And I'm going to put the letters in the same order in which they are in the problem. So if ABC goes left, top, right, then RST must also go left, top, right. Now, I look to see what corresponds. Choice 1, angle A and angle R, do they correspond? Yes. Choice 2, A and S, do not correspond. They're not in the same position. Choice 3, CB and TR, CB and TR, they do not correspond. And CA and CS, they do not correspond. My answer is choice 1. We'll call that level 1 of this. Now we'll take a look at level 2. Not that it's hard. Same thing. I don't like these pictures. I'm going to draw my own pictures, and I'm going to label them the way the letters are in the problem. So ABC is left, top, right. So DEF is left, top, right. I am going to use this picture, though, just to put the numbers in the right spot. CB is 13. CA is 15. AB is 16. And DE is 2x minus 1. So because it's giving me an algebraic expression, I need to create an equation. Well, what does 2x minus 1 correspond to? It corresponds to the 16. So I'm going to set 2x minus 1 equal to 16. I solve the equation. That'll give me my answer. We can use the equation solver. We'll talk more about the equation solver later. I'm not going to talk about it now. X equals 8.5. All right, what's next? All right, min rotation is 360 over n and any multiple of that. First off, I need to know my vocabulary. Pentagon has 5 sides. Hexagon has 6. Octagon has 8. Nonagon has 9. Decagon has 10. So you are responsible for knowing that vocabulary. Min rotation is 360 over n. Hexagon has 6 sides. So step 1, I do 360 over 6. Use our calculator if we need to. 360 divided by 6 is 60. Now I don't see that there. And any multiple of that. So which of these is a multiple of 60? Well, it can't be smaller than 60. And if you're not sure, I'm going to take my calculator and I'm just going to divide each of the possible choices by 60. So choice 2, is 90 a multiple of 60? No, it doesn't go unevenly. Is 180 a multiple of 60? Yes, it does go unevenly. Is 270 a multiple of 60? No, it doesn't go unevenly. The answer is choice 3, because 60 times 3 is 180. We find the minimum rotation by doing 360 over the number of sides, and then any multiple of that will also map it onto itself. That brings us to line of reflection equals line of symmetry. Center rotation equals center of shape. What you do need to know for this lesson is Yancey. Yancey has X-ray vision, which is what I use to know that y equals a number is a horizontal line, and x equals a number is a vertical line. So we do need that vocabulary for, or I don't know if you want to call it vocabulary, but that piece of information for this lesson. So the two rules are line of reflection equals line of symmetry. So for a reflection, the line of reflection must be a line of symmetry, meaning it must cut the shape in half. So the x-axis, is the x-axis a line of symmetry? Does it cut the shape exactly in half? Yes. X equals 4. Well, we need to know that x equals 4 is a vertical line at 1, 2, 3, 4. That's my x equals 4. So is that x equals 4 a line of symmetry? Does it cut the shape exactly in half? Yes. Center rotation equals center of shape. For my rotation, the center of rotation must be the center of the shape. So choice 3 has got me centered at the origin. Is the origin the center of the shape? No. Choice 4 has got me centered at 4, 0. Is that the center of the shape? Yes, that is the center of that rectangle. Which one will not map it onto itself? Choice 3. Line of reflection equals line of symmetry. Center rotation equals center of shape. That's what you need to know for that commonly asked, not hard, Regents question. Join the midpoints. This is a simple question if you know the rule. You need to know this picture, and you need to know the vocabulary. It has to say that they're midpoints. When midpoints are joined, the rule is 2 times the midsegment equals the opposite side. So if AC is x plus 15 and DE is x minus 3, it's 2 times the midsegment, so 2 times x minus 3 is equal to the opposite side, x plus 15. From there, you solve the equation. I think it's a good opportunity to show the equation solver. If you can't do algebra, we can math up. Math up, enter. Type the left-hand side into E1. Type the right-hand side into E2. Graph the number 10, graph, and it'll tell you your answer. The reason I hit 10 is I'm just telling it if there's a positive and negative answer, I'm telling it I want the positive answer. Any number's fine. I just choose 10. If I'm doing the algebra, I distribute minus x, x minus 6 equals 15, and I solve. Now make sure you always read carefully. The question's asking for DE, so DE is x minus 3. So DE is 21 minus 3, which is 18. And again, to use that equation solver, I'm sure I went kind of fast there. I hit math, up arrow, and enter on numeric solver. And if you ever want to get out of anywhere, second quit will get you out. All right, next rule. We got our candy corn problems. Candy corn bases separate. If there are no bases, put the top over top, the side over side, and the bottom over bottom. Are the bases involved? No. The bases are the parallel sides. That's the vocabulary I use. So if there are no bases, I'm going to put the top over the top, or the bottom over the bottom, or the side over the side. Do I have both tops? Yes. So I put 9 over 9.2. Do I have both bottoms? No. This bottom is blank, so I'm not going to put the bottom over the bottom. Side over side. Do I have both full sides? Well, yes. This whole side is 9 plus 5, which is 14. This whole side is x, so I put my side over my side. From there, I cross multiply and solve. 9 times x is 9x. 9.2 times 14 is, time to go get a calculator, 9.2 times 14 is 128.8. 128.8 divided by 9 to the nearest tenth is 14.3. So if the bases are not involved, we put the top over the top, the bottom over the bottom, the side over the side, and expect to have to add or subtract pieces. If the bases are involved, candy corn, bases separate. Now the bases are involved, always put an X on what you're trying to find. I like to always color on the top of my candy corn so I can see what's going on. Separate the triangles. So draw them as accurately as possible. The big triangle, A's up top, C's in the bottom left, B's in the bottom right, and then DEB. I'm going to put the information into both pictures. So the small triangle, DE is 4 and DB is 12. Expect to have to add or subtract pieces. AB is 36. And now that I have that, I just put my corresponding sides on top of each other. X corresponds to 4. 36 corresponds to 12. And then I cross multiply and solve. 12x equals 144. Of course, you can use a calculator if you need to. X is 12. And this document and the answer key can be found on Schlansky.com, and I will make sure that I post that link in the description. Hill-Sass, you got to recognize this picture. Hill-Sass. This is the vocabulary that you need to know to do Hill-Sass. If there's an L involved, we're going to use Hills. If there's an A involved, we're going to use Sass. That got a little messy, so I'm just going to get rid of that. Put the information into the picture. RV is 4.1, TV is 10.2. It's asking for ST. Is there an L involved? Yes. So I'm going to do Hills, H over L equals L over S. H is this whole thing. I need to add them together. That's 14.3. Over L is X equals L is X. It's always the same leg used twice. And since I'm using the right leg, I'm using the right seg, 10.2. From there, I cross multiply and solve. X times X is not 2X. X times X is X squared. 14.3 times 10.2 is 145.86. I don't want X squared, I want X, so I do the square root. The square root of 145.86 is to the nearest tenth, 12.1. I did the nearest tenth because it said to round to the nearest tenth. So that's a Hills example. Now, if I take a look at number 31 here, it's the same picture. It's upside down. It's going to be okay. It's going to be okay. It's just upside down. L involved or A involved? Well, there's no L involved here. Is there an A involved? Yes. And again, you can refer to this picture. So if there's an A involved, I'm going to use SAS. So we're going to go S over A equals A over S. This S is 7 over A is X. equals A is X. Little problem, I don't have this seg, but if the whole thing is 16, I can subtract this 16 to 7 to get 9. Again, expect to have to add or subtract pieces. X and X is X squared. 7 and 9 is 63. It wants it to the nearest 10th. Square root, square root. Type that into the calculator. And I get 7.9. This whole unit is all about little pictures and knowing your rules. I have a document on Schlansky.com. I have a couple documents on Schlansky.com, but key pictures, it's not that big of a document, but basically you need to know these pictures and what to do with each of them. We talked about the midpoints. When you see that picture with midpoints, we do midpoints. You got to recognize your candy corn picture, your Hill-Sass picture, among others. So we may refer back to this as we go through. And the other document on Schlansky.com, which we're going to refer to a little bit, is my enhanced reference sheet, which we're not going to talk about right this moment, but it's basically everything you need to know, especially including all the formulas that you need to just basically be able to build and have memorized. All right, back to this. We're going to now do Hill-Sass multiple choice. So you need to know how to do Hill-Sass in order to do Hill-Sass multiple choice, but if you do, it's simple. Basically, which of the choices is it correctly subbing into Hills or Sass? So I'm going to label everything first. This is my H. I'm going to call this L1 and L2 and S1 and S2. Since my left leg has to go with my left seg, I'm going to call those 1, and the right ones I'll call 2. And that's my A. So I'm going to start with choice 1, RV. RV is S1 over VS is A. So far it looks like it could be Sass equals VT is S2. So I'm going to stop right there. That's not correctly subbing into Sass. That's not correct. Choice 2, RT. RT is H. Okay, over RS is L1. All right, looking good. Might be Hills. RS, L1 again, good. VT, oh, VT, it is an S, but it's the wrong S. If I'm using the left leg, I need the left seg. It gave me the right seg. So even though it's Hills, it's not correct. It's the wrong seg. How dare they? All right, choice 3, RT, H over SV, A. Nope, there's no ha. And finally, choice 4, let's hope this works. RT. RT is H over ST. ST is L2 equals ST. L2 over VT. Yes, that's S2. That's Hills. It's set up correctly. That's your answer. Perimeter times the scale factor. Area times the scale factor squared. I like this pink. I think I'm going to stick with the pink for a while. When it's asking about perimeter area scale factor, it's perimeter times the scale factor. And it's area times the scale factor squared. So the original perimeter is 10. The scale factor is 2. So the new perimeter is going to be 20. Area times the scale factor squared. Oops, I made a mistake. How dare I? The original area is 12. So it's 12 times 2 squared. You can use a calculator if you want. 12 times 2 squared is 48. So the new area is going to be 48. Perimeter times the scale factor. My original perimeter times the scale factor. Area times the scale factor squared. My original area times the scale factor squared. Ooh, which brings us to SOHCAHTOA. Very, 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 very important. 8 points, 10% of your exam is SOHCAHTOA. So let's make sure we can do our SOHCAHTOA. Step 1, we want to label our H, our A, and our O. H is the hypotenuse, the long slanted side opposite the right angle. The angle always connects the H to the A, which makes O my opposite, the side that's not touching the angle. Out of the H, the A, and the O, which two are involved? Well, H and O are involved, and H and O is sine. So I write sine theta equals O over H. Theta is the angle, which in this case is X. O is 17. H is 28. Now, there's two ways that's bothering me that 17 is blending together. There we go. From here, we can do this the right way or we can do it the shortcut way. Let's do it both. If you can set up the ratio but you don't know how to solve it, then just math up. Make sure either way your calculator must be in degree mode. I am in degree mode. I hit mode and I hit degree. And I math up and I type in sine x to the left-hand side. And I type in 17 over 28 on the right-hand side. And I hit graph 10 graph. And to the nearest tenth, am I asking for the nearest tenth? Nope, nearest integers, so 0 decimal places, x is 37. Now, ideally, you know how to do it. When you're trying to find the angle to get rid of sine, I do inverse sine. So it would be great for you to do this, but not 100% necessary. Inverse sine is 17 over 28. Again, to get out of here, second quit, which is right next to the second button. So I hit second sine for inverse sine, 17 over 28, and I'll get that same value, 37. Let's go back to pink. I'm enjoying this pink. Step one, label my H, my A, and my O. A and H are involved. That's cosine. So it's cosine theta equals A over H. Theta is always the angle, which in this case is 26. A over H is 14 over X. If you are one of the many students who can get to this point but don't know what to do next, then math up. Math up, enter, left-hand side, cosine 26, right-hand side, 14 over X, graph 10, graph, to the nearest integer, X is 16. If you're doing it algebraically, I'm not doing inverse since X is in the fraction. Once X is in a fraction, I cross multiply and solve. Follow the loops. X times cosine of 26 is X cosine 26 equals 1 times 14 is 14. Divide both sides by cosine of 26 to get X by itself. I go to my calculator. I go 14 over cosine 26, and I get that same value of 16. You need to know how to do your SOHCAHTOA, so there's plenty of examples here. Then I go into some ones where you have to just kind of draw your own picture. I'll just draw the picture here. It's really not hard to draw. It says right triangle JOE. It says JO is the hypotenuse, so JO I'm going to label there and there, which means that E would have to be the right angle. JO is 31.8, angle J is 38. It's asking for EJ, put an X on what you're trying to find, and now from there it's the same thing. So don't be afraid to draw your own picture. Just start drawing it, put the letters where it says to, and you should be fine. Now, this may not be a Schlansky's Guide to 65 question, but I gotta do it. This question, they asked like 70% of the time was a 4-point question. Hasn't come up for a few exams, so either it's due or they're moving away from it, but I'm gonna make sure that all my students are prepared for this picture. Again, this picture is on your key picture sheet. It's a right triangle inside of a right triangle, and when you see this, the number one thing that I want you to think is subtraction. If I'm going to find A to D, well, A to D is not a side of the right triangle. I'm going to draw the two right triangles separately. So I'm going to do, let me just zoom out, get some space here. I'm going to draw the big right triangle, B, C, A. I'm going to draw the small right triangle, B, C, D. Now, since I want to find the bottom side here, I'm going to find the bottom side of each of the right triangles. If I want to find the right side, I find the right side. If I want to find the angle, I find the angle. I find the corresponding side of each of the right triangles. I put the information into this picture. That's 7, that's 16. They both have BC, which is 125. And now I'm going to do SOHCAHTOA for each of them. So I'm going to do, let's go back to my pink, HAO, HAO, SOHCAHTOA. I have O and A, tangent. So I have tan theta equals O over A. I have tan theta equals O over A. I have tan 7 equals 125 over X. I have tan 16 equals 125 over X. I'm just going to move them into space. I cross multiply and solve each of them. So I have X tan 7 equals 125. I have X tan 16 equals 125. And again, you can use the equation solver if you need to, but you don't want to round until the very end. So if you're going to do that, write out the whole decimal that it gives you. X equals 125 over tan of 7. One 25 over tan of 7 is 1018. Dot, dot, dot. 125 over tan of 16 is 435. Dot, dot, dot. Now, I don't have to put it into the picture, but it might be helpful for you to see what's going on. So I just found, let me get rid of that SOHCAHTOA at this point. I just found that this whole thing is 1018, dot, dot, dot. I found that this right here is 435. So now to find that missing piece, I'm going to subtract. I'm going to do 1018, dot, 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 minus 435, dot, dot, dot. I'm going to copy and paste those in my calculator. That's what the dot, dot, dot means. It means I'm not going to write the whole thing out because who's got time for that? But I'm going to copy and paste those values. The final answer says to the nearest foot, 582. I can't tell you how many of my students have passed on that, knowing how to do this question. That's it. And now we've got sine A equals cosine B. A plus B equals 90. Whenever you see sines and cosines, the rule is sine A equals cosine B. But A and B must be the acute angles, not the right angle, but the acute angles. So for 52, it says the right angle's at M. So that means the right angle must go at M. There's my T and my R. And my A and B are, in this case, T and R. So I'm looking for sine and cosine. I'm looking for T and R. That's not T and R. That's not T and R. That's not T and R. I've got my T. I've got my R. I got my sine. I got my cosine. That's my answer. It doesn't matter if it says cosine of T and sine of R, as long as I have a sine and a cosine and a T and an R. And the reason it's T and R, my A and B are my acute angles, not my right angle. Which brings us to a related question. I see sine A equals cosine B. Well, it doesn't say sine A equals 2x plus 7. A is what comes after sine. B is what comes after cosine. And the rule for A and B is A plus B equals 90. So A 2x plus 7 plus b, 4x minus 7, must equal 90. From there, I combine like terms, 6x, the 7's cancel, and I solve the equation. And yes, you can use the equation solver if you need to. X equals 15. It's asking for the value of x. Choice 2. All right, let's keep on rolling. Do we have a new unit? We sure do. Only problem with this is I need my Play-Doh. So if you need something in more detail for cross sections or plane sections, watch my video for that where I have my Play-Doh and I'm slicing it. But basically what you need to know is a plane section or cross section is a two-dimensional slice of a three-dimensional object. Parallel to the base is going to be horizontal. Perpendicular to the base is going to be vertical. And we're looking at the two-dimensional shape that's created. Parallel to the base is going to always be the base. So if I'm parallel to the base here in number 59, what shape is the base? A circle. Perpendicular to the base, again, means vertical, straight up and down. And for perpendicular to the base, if it's a prism, any prism or cylinder, it's going to be a rectangle. A pyramid or a cone would be a triangle. So perpendicular to the base in this case would be a rectangle. So again, it's a two-dimensional slice of a three-dimensional object. If you're looking at this and you're like, I don't get it, watch my video on cross sections where I'm actually slicing the Play-Doh up, or just, ask me because I'm around, potentially, depending on where you are. Area on the grid. Again, an easy question, not hard, but you have to know how to do it. Step 1, we build a rectangle around the shape. I kind of follow A and B to where they would meet. I can go bigger than this. I follow B and C to where they would meet, and C and A, and I build my rectangle. Now I'm going to count point to point. So don't count squares, count point to point. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6. I find the area of the rectangle. Area of a rectangle is length times width. My length and width are 6 and 12. Use a calculator if you need to. 6 times 12 is 72. Now I'm going to find the area of each of the triangles. And the triangles are half length times width. Now I'm just going to do this part in the calculator. So this triangle right here, the length and width are 6 and 6. So I'm going to do half 6 times 6 is 18. This one here, it's 6 and 3. So I'm going to do half 6 times 3. And then I've got 12 and 3 here. So I'm going to do half 12 times 3, 18. Now I'm going to take my triangle areas and I'm going to add them up. Use a calculator if you need to. And I'm going to subtract that from my rectangle area. And my answer is 27. So build a box around the shape. Find the area of the rectangle, length times width. Find the area of each of the triangles, half length times width. Add them together, subtract from the rectangle. Which brings me to triangle area, half AB sine C. Area of a triangle is half AB sine C, where A and B are the sides and C is the included angle. You need two sides in the included angle. So since my angle is 38, which sides make up that 38? The 15 and the 18. So it's A equals half 15, 18, sine 38. And then you just put that into the calculator. half 15, 18, sine 38. I said to round to the nearest, I don't know, something. I don't know. I didn't write it. Oh no. Well, whatever. Whatever you want. Let's go to the nearest integer. 83. You need two sides and the included angle. Triangle area, half AB sine C. Population density. This is where you need to start knowing your formulas, and I have songs to know all this. I'm at Math Schlan. You know where my YouTube channel is. You're on my YouTube channel right now. I'm on Spotify, Apple Music, all that stuff. You need to know your songs. You know your songs. You know your formulas. So on my enhanced reference sheet, I wrote out everything. You need to know your population density formula. It's PD-PA. DMV, PD-PA, density is mass over volume. It didn't make its way onto this video. It'll be on another video that not as commonly asked questions. And this has been on two of the first three of the next gen exams. That's why we're doing it. Population density is population over area. So I've got town A and I've got town B. And for each of them, I'm going to do population over area. Town A has a population of 8198. Town A has an area of 12. Town B has a population of 7384. Town B has an area of 10. So I'm going to go 8198 divided by 12. I got 683 dot dot dot. 7384 divided by 10. I've got 738.4. Which one has a greater population density? Town B. Population density is population over area, PD-PA. Which brings us to volume. You need your volume formulas. The reference sheet they give you is garbage, man. This thing has got nothing. If anything, it makes things worse. The only thing that's helpful is sphere. Everything else we cross out, those capital B's, make things more complicated, more annoying. So we're going to build our volume formulas. Volume equals, go back, pick, length times width times height, and pi r squared height. 3 length times width times heights. 2 pi r squared heights. 1/2 is for triangle. 1/3 pyramid and cone. That's your cylinder. That's your rectangular prism. We built it. We have them. Once we have them, volume is real simple. So I'm not going to go through all the volume examples because it's just subbing into the formulas. What do you need to be careful of? Well, if it says in terms of pi, don't type pi in, but make sure you include pi in your answer. If it's rounded to whatever, then you do type pi in. And you definitely need to know that the radius is half of the diameter. So if the diameter is, let's say, 10, then the radius is 5. So I'll do a couple of them, but we'll really do more when we get into applications of it. So it's telling me that the pyramid has a square base. Most of the time, the pyramid is going to have a square base. That means if the length is 6, then the width is 6 as well. A square base, the length and width are the same. A lot of students get caught on that. The altitude is 12, so that's my height. I write down my formula for the volume of a pyramid, which I built. Volume of a pyramid is right there. 1/3 length times width times height. So it's 1/3 6 times 6 times 12. And I put that into the calculator, and that gives you my answer. 1/3 6 6 12. 144 cubic inches. I'm not going to do more of this right now. Again, it's just subbing into a formula. If it says nearest cubic inch, that means I am typing pi in. In number 75, there's pi's in the answers, so don't type pi in. And also for number 74, this is my diameter, which means my radius would be 4. Calculating volume with basic dimensional analysis. So the assumption is that you understand basic dimensional analysis. If you don't, then watch my video on dimensional analysis. Whenever it's asking for cost or mass or whatever, step 1, calculate the volume. A spherical balloon, so I go to my reference sheet. Sphere is the one thing that is given to you, 4/3 pi r cubed. So I write down V equals 4/3 pi r cubed. The radius is half of the diameter, so if the diameter is 1.7, then the radius is 0.85. I go to my calculator and I type that in. 4/3. Again, especially because I'm doing applications now, I am typing pi in. Most of the time you're typing pi in, unless it says in terms of pi, or there's pi's in the answers, but that'll generally just be a volume question. If it's any application, you're going to be typing pi in. So I've got 2.57 ... cubic feet. Now I start my dimensional analysis. So let's go a new color. Let's go back to pink. I've got my 2.57 ... cubic feet. I make a fraction. I want cubic feet to cancel, so cubic feet goes on the bottom. I'm looking for cubic feet. There it is. I'm changing it into money. Units first. 0.80 goes with the money. It says per cubic foot, so that's 1 cubic foot. The cubic feet cancel. I have money. I'm asked for money. They're both on top, so I'm just multiplying by 0.80, and I get 2.06. With money, if it doesn't specify otherwise, 2 decimal places nearest set. Find the volume, do your basic dimensional analysis. Again, if you don't understand the basic dimensional analysis, then watch my video on that. 3D rotations, I can do this on paper. The concept is I got a flag on a flagpole, I'm spinning it around continuously. So I can do this 2-dimensionally. Step 1, I'm going to reflect the shape in 2 dimensions. So it wants me to rotate around MH. So I'm going to start by reflecting over MH. And I connect the original and the image with curves. What am I looking at? I'm not looking at a pyramid. I'm looking at a cone. The radius of that cone is 8. The height of that cone, the height of that cone is 5. Reflect in 2 dimensions, connect with curves, and that's it. Line dilations, listen, this is the guide to 65. We're just going to do the cheat, all right? The cheat works like 75% of the time. The other 25%, it is a bit complicated. We're going to go with the cheat. Line dilations, parallel, keep the slope. This is not the cheat. No matter what, when I'm dilating a line, the slope is always the same. So the slope is 3, so those are out. The slope is 3, so those are out. The cheat, not origin, same line, not origin, same line. If the center of dilation is not the origin, it's the same line. Origin, multiply scale factor and B. If it's centered at the origin, I'm multiplying the scale factor and the original B for the new B. My new B is -4. My answer is choice 2. If the center of dilation is the origin, multiply scale factor NB. If my center of dilation is not origin, it's the same line. That's the cheat. Why? Because if the center of dilation is on the line, it's the same line. And whenever it's not origin, it's always been on the line. If I basically sub x and y into y equals 3x minus 2, I get 5 equals 3 times negative 1 minus 2. Negative 5 equals. And that shows that it's on the line. And if it's on the line, it's the same line. But the cheat works most of the time. That's what we're going to roll with, at least in Schlansky's guide to 65. Graphing circles. I need center and radius. To get the center, I negate what's in the parentheses. If there are no parentheses, the coordinate is 0. So I negate what's in the parentheses. The x-coordinate's positive 5. The y-coordinate's negative 1. I'm changing the sign of what's in the parentheses. That's my center. The radius is the square root of the right-hand side. The radius is the square root of 9, which is 3. So I'm looking for a circle with a center at 5, negative 1. And a radius of 1, 2, 3. Negate what's in the parentheses for the center, square root of the right-hand side for the radius. And if there are no parentheses, then the coordinate is 0. So let's just say that I had an equation that was x squared plus y minus 1 squared equals 4. The x coordinate of the center would be 0. The y coordinate would be 1, and the radius would be 2. That brings us to completing the square with circles, or conics app. I go back and forth. Do I want to show you this the right way? No, I don't. This is Guide to 65. We're going to use the conics app. If you know how to do it with completing the square, you're awesome. So for center and radius, when it's in standard form, we go to our conics app. We hit apps. We go to conics. We hit enter. We go to circle. We go to option 2 because that's the form it's in. Now we see how it says equals 0 here. Right now, mine does not say equals 0. So I'm going to have to subtract 23 from both sides. It's helpful to write it in the right form, x squared plus y squared plus 6x minus 4y minus 23 equals 0. But it doesn't really matter. But that 23 has got to come over. It's got to be equal to 0, because if it's not equal to 0, then your d value is going to be wrong. I'm going to list my a equals, b equals, c equals, d equals. And it tells you what each of them are. A, it says, is what's in front of x squared. A is going to always be 1. B is what's in front of x, which in this case is positive 6. C is what's in front of y, which in this case is negative 4. D is the constant, which is negative 23. I input those. It tells you what to press. It says alpha solve. That's alpha enter. Center is negative 3, 2. Radius is 6. I'm done. I'm not worrying about completing the square. I'm not doing it. I'm not doing it. Again, make sure it's equal to 0. That's the biggest issue students have. And to get out of anything in the calculator, second quit will always get you out. Second quit. So again, that was apps, conics. It may not be option 4, but it'll be somewhere. Circle, option 2. Make sure it's equal to 0. A is always 1. B is what's in front of x. C is what's in front of y. D is your constant, as long as it's equal to 0. If it's not equal to 0, we had to move it. All right, another very easy question if you know how to do it, and it's asked on every single Regents. When I'm partitioning a directed line segment, I do delta x over p, delta y over p. So I'm going to plot the points, and if there is no graph, then use the graph paper attached to the exam. A, B. P is the total number of partitions, so I'm adding the pieces in the ratio together. 2 plus 3 is 5. And for delta X and delta Y, I'm going to count. So let's get this bigger. Delta X is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Delta Y is 1, 2, 3, 4, 5. So it's 10 and 5. So I've got 10 and 5. 10 over 5 is 2. 5 over 5 is 1. So now I'm going to count 2 in the X direction and 1 in the Y direction on the grid. 2 in the X, 1 in the Y, 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 2 in the X, 1 in the Y. Now I'm starting at A because it says AP to PB. It has to tell you which one you're starting at. So A is going to be 0.0. This is 1, 2, 3, 4, 5. And whichever number comes first in the ratio, in this case 2, that's my answer. What are the coordinates? -2, -3. Which brings us to our circle rules. Well, if we go back to our enhanced reference sheet, you got to build this. 2EA equals major minus minor. 2VA equals arc plus arc and 4 segments. Use PP and we. These are your arcs and angles rules. These are your segments rules. What's the difference between an arc and angle and a segment? Well, I'll talk to you about that in a moment. E stands for exterior in both cases. So if there's an exterior piece, you're using the formula with the E. If not, then you're not. So first of all, let's talk about vocabulary. Arc, arc, segment, segment, angle. So when I say arcs and angles or segments, that's what I'm talking about. All right, this is a segment, this is a segment, this is a segment, this is an angle, this is an arc, this is an arc. So arcs, let's put the information into the picture. Angle RPS is 35. Arc RS is 121. It wants arc WT. Arcs and angles are segments. These are arcs and angles. So arcs and angles are either 2EA or 2VA. Is there an exterior angle? Is there an angle outside the circle? Yes. So it's 2EA equals major minus minor. From here, it's easy. The exterior angle is 35. The major arc is the big arc, that's 121. The minor arc is the small one, that's X. And I do the algebra, or I use the equation solver. Either way. To get rid of the negative, I would divide by -1, and X is 51. Number 98, arc AC, blah, blah, blah. How many degrees are an arc dB? Arcs and angles are segments. Arc, arc, angle. So my arcs and angles are either going to be 2EA or 2VA. Is there an exterior angle, an angle outside the circle? No. So it's going to be 2VA, which is 2VA equals arc plus arc, where VA stands for vertical angle. This is a vertical angle. So it's 2 times 58 equals arc plus arc, 72 plus X. From there, either do the algebra, use the equation solver. It's 116 equals 72 plus X. And I get my answer. Number 99. AD is 6. AC is 9. It's asking for AB. Arcs and angles are segments. Those are segments. 4 segments. Use PP. And we. E, is there any exterior piece? Yes, this is all outside the circle. So it's going to be we. If you don't know what we stands for, you're not going to get this correct. It's whole times exterior equals whole times exterior. So it's going to be the whole times the exterior for the pink. The whole thing is 6. The exterior piece is 6. When I have a tangent, the whole and the exterior is the same thing. Now I take a look at the purple segment. What's this whole purple segment? 9. What's the exterior part of the purple segment? X. And for both PP and we, it's multiplication. And from there, I solve the equation. 6 times 6 is 36. Divide by 9. X is 4. All right, number 100. I got BR is 10. I've got BE is 4. I got AE is 8. I want ES. Arcs and angles are segments. These are segments. 4 segments. Use PP. And we. Is there an exterior piece? No, there's nothing exterior. So it's PP equals PP, which stands for part times part equals part times part. So it's going to be the part times part for the red equals the part times part for the green. Let's start with the red. The two parts are X and E. Now a little twist on the green side. The two parts, well, I don't really have them right now. I have the 4, but I don't have this part. But if the whole thing is 10, then this part would have to be 6 equals 4 times 6. And now from here, I just do the algebra, and I get my answer. The math is pretty simple. The hard part is knowing the rules. So again, 2EA equals major minus minor. 2VA equals arc plus arc. Those are your rules for arcs and angles. And 4 segments, use PP. And we, where 2EA is 2 times the exterior angle, 2 times the vertical angle, part times part equals part times part, whole times exterior equals whole times exterior. All right, that brings us to, back to our reference sheet, theta pi r squared over 360. This thing's getting a little messy. Theta pi r squared over 360. Theta pi d over 360. Area of a sector, arc length of a sector. You build it, you have it. Very simple. There could be twists. We're not going to focus on the twists here. Area of a sector is theta pi r squared over 360. So A equals theta pi r squared over 360. AOC is 70. AO is 2. Theta is the central angle. I've got it. R is the radius. I got it. And that's it. Just like volume, it says to the nearest tenth, so I am going to type pi in. It could say in terms of pi. Often it does say in terms of pi, but again, we talked about that earlier. 70 pi 2 squared over 360. To the nearest tenth, 2.4. Area of a sector, theta pi r squared over 360. Arc length of a sector is theta pi d over 360. So it's asking for the length of an arc. That's theta pi d over 360. Theta is 36. Be careful. So AB is 20. That's a radius. So the diameter would be 40 over 360. It says in terms of pi, so don't type pi into the calculator. So I've got 36 times 40 over 360. So I'm not typing pi into the calculator, but make sure you have a pi in your answer. So I got 4, but the answer is not 4, it's 4 pi. Oh man, we're almost done. That's it. Coordinate geometry proofs. I'm going to try and keep this relatively short, but this is a gift of a 4 or 6 point question, but you need to receive that gift by knowing your how do you proofs. So I do everything with distance. You're always calculating distance except for trapezoid, in which case you're calculating slope. You're always calculating distance except for trapezoid, in which case you're calculating slope. So I'm going to do one. I'm going to talk through some answer keys for the others, and then we're going to be done. So it wants me to prove that there's an isosceles right triangle. So step one, I'm going to write what they want me to prove because I'm going to try and keep some space here. So it wants me to prove that there's an isosceles right triangle. So I'm going to write 1, and I'm going to say that triangle ABC is an isosceles right triangle because, well, the answer to that is right here. Isosceles, two congruent sides, right triangle, the sides fit into Pythagorean theorem. So the rest of this sentence for part 1, for step 1, whatever you want to call it, is here. You're going to have this memorized at a certain point. So because it has two congruent sides and the sides fit.
Good morning.
The sides fit into Pythagorean theorem. So now I'm going to find all the distances. So let's get this onto the grid at this point. A is -2, 4. B is 6, 2. C is 1, -1. I don't have to draw the lines and connect them. It doesn't really matter. So I'm going to find the distance of AB. I'm going to find the distance of BC. And I'm going to find the distance of CA. So distance equals radical delta x squared plus delta y squared. So I'm going to count A to B, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. 8 squared plus 2 squared. 64 plus 4. 68. Radical 68. Oh boy, yes. We had a student get a 64 on the Regents because he did not put radicals over his answers. Oh my God, that was painful. Don't let that be you. BC, 1, 2, 3, 4, 5. 1, 2, 3. 5 squared plus 3 squared. 25 plus 9. Radical 34. CA, 1, 2, 3, 1, 2, 3, 4, 5. 3 squared plus 5 squared. 9 plus 25. Radical 34. All right, now that I found my distances, step 3, I'm going to tie it all together. In step 1, I said that it has two congruent sides. So what are my two congruent sides? Well, BC is congruent to CA, because they have the same distance. Now, the Pythagorean theorem is different than everything else. Everything else, blanks can grow into blank because they have the same distance, or blank is parallel to blank because they have the same slope. But to show the sides fit into Pythagorean theorem, I'm going to do Pythagorean theorem. A squared plus b squared equals c squared. So a and b are the smaller sides, rad 34 plus rad 34 squared equals c, rad 68 squared. The squares and the radicals cancel. I have 34 plus 34 equals 68. 68 equals 68. And that's how I show the sides fit into Pythagorean theorem. So one, and I'm just going to transition to this because it's neater. I know that's not super neat what's on there. One, I'm going to state what they want me to prove because, and again, the answer to that is this. Okay, you have to know how to prove your different shapes. Step two, find your distances using your distance formula, which is delta radical delta x squared plus delta y squared. And then tie it all together in step three. Tell me what's congruent to what because they have the same distance. And if you're showing it fits into Pythagorean theorem, then you're showing it fits into Pythagorean theorem. Next is the rhombus but not a square. And again, I'm not going to do it because it's just the same thing I just did. I'm going to talk through it to save some time, but you don't need to sit here and watch me do everything I just did. So the PQRS, do I have PQRS? I sure do. So I'm going to, in one, I state what they want me to prove. PQRS is a rhombus because all sides are congruent. And again, that's coming from right here. It wants me to prove that it's not a square. So I say that it's not a square because the diagonals are not congruent. And again, if I go back up here, to prove it was a square, I would prove it did have diagonals congruent. So to prove it's not a square, prove it doesn't. From there, I did all my distances, which again, we talked about. And then in my third step, I stated what's congruent to what because they have the same distance, and what's not congruent to what because they don't have the same distance. And for the rhombus, to show that all sides are congruent, I just write that PQ is congruent to QR, is congruent to RS, is congruent to SP. That's how I see that they're all congruent. I'm going to do the trapezoid to some extent because we haven't done slope yet. So one DEFG is an isosceles trapezoid because and again, I can go back up to that list. It has one pair of opposite sides parallel. And it has congruent legs. And again, both of those things I'm getting from that list, and you are going to have to know these if you want to get the points. So D is 1, 3, E is negative 1, 1, F is negative 1, negative 2, G is 4, 3. So now, in order to show that it has opposite sides parallel, well, parallel has the same slope. It's pretty clear to me what the parallel sides are, ED and FG. So I'm going to find the slope of ED. I'm going to find the slope of FG. Distance equals radical delta x squared plus delta y squared. Slope equals delta y over delta x. Slope is delta y over delta x. So ED, I'm going up 2, right 2. 2 over 2. I always go left to right. So if I'm going up and right, it's positive. If I'm going down and right, it's negative. You do need to reduce the fraction. 2 over 2 is 1. FG, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 over 5. That reduces to 1 as well. So the reason I wanted to do this one for you, I just wanted to do slope for you. Now that I did the slope for you, I'm going to go back to the key because it's neater and I can just talk through it. Again, we just wrote out 1. It's an isosceles trapezoid because I found the slopes and I found the distances because I needed the congruent legs. And I stated the one pair of opposite sides parallel because they had the same slope and the congruent legs because they have the same distance. There's one more problem to go over. We're going to do part of it. We're not going to do the whole thing. In fact, I can do it right on the screen here. This is a very, very commonly asked 6-point question. 3 parts to it. Part 1, prove it's a right triangle. Well, we did that already. That's here. It's a right triangle because the sides fit into Pythagorean theorem. Distance, distance, distance. Show that it fits into Pythagorean theorem. Done. The next part's the what I want to talk about. State the coordinates of point P such that quadrilateral RSTP is a rectangle. RSTP. Well, right now I just have RST. So if RSTP is going to be a rectangle, I know that it's going to be somewhere in this general area. So to figure out exactly where it is, I'm going to count. Whatever I do to get from S to R, I'm going to do the same to get from T to P. So from S to R, I'm going 1, 2, 3, 4, 5, 1, 2, 3. So I go 1, 2, 3, 4, 5, 1, 2, 3. That's my point P. I state the coordinates of it because it said to state the coordinates of it. And now I have point P. Done with that part of the problem. Now it says to prove that RSTP is a rectangle. So I prove the rectangle. RSTP is a rectangle because I go back to my list. It has 2 pairs of opposite sides congruent and diagonals congruent. I already did these 3 distances, so I don't have to do those 3 again. I do the other 3 distances. And then I state what's congruent because they have the same distance. So be prepared for your coordinate geometry proof because it's an easy 4 or 6 points if you know how to do it, if you know how to do your distance. But again, you're going to have to memorize your how do you proofs. And on the enhanced reference sheet, just like everything else on this section right here, that's kind of not using words, but using pictures, how you're proving all the different shapes. So I'm going to very, very quickly recap everything that we just talked about, and then you can be on your way. Listen, I say it's guide to 65. This should be enough to get a 65. I can't promise that. The next video will be the not hard questions that come up often, not all the time, but often. And then we'll have one on the commonly asked questions that do have a degree of difficulty. But this one I think is definitely the most important, especially if you're trying to get to that 65. So here we go. Let's go with color reviews yet. Orange. Sides of a triangle, the 2 smallest sides must add to be more than the 3rd side. If they give you 2 sides, you add them onto each of the possible choices, and then you do the same thing. The 2 smallest must add to be more than the 3rd. Draw your own triangles or quadrilaterals, whatever. We'll put the letters in the same way, and then see what corresponds to what. If it's algebra, set the corresponding pieces equal to each other. Min rotation is 360 over n and any multiple of that. Line of reflection equals line of symmetry. Center rotation equals center of shape. Midpoints, 2 times the midsegment equals the opposite side. Candy corn, bases separate. If the bases are involved, separate the triangles. If there are no bases, put the top over top, the bottom over the bottom, the side over the side. Hill SAS, if there's an L involved, use hills. If there's an A involved, use SAS. Expect to have to add or subtract pieces. And if it's multiple choice, you just see which one fits into hills or SAS. Perimeter times the scale factor. Area times the scale factor squared. SOHCAHTOA, Label your H, your A, and your O, sub into the appropriate formula, use the equation solver if you need to, otherwise inverse for an angle, cross multiplication for a side. When you see this picture, subtraction, draw the two right triangles. If I want to find the bottom for each, using SOHCAHTOA, and then subtract them. Very commonly asked 4-point question. Sine A equals cosine B, where A and B are the acute angles. A plus B equals 90. When it's sine of something equals cosine of something, those somethings add to 90. Cross sections or plane sections, parallel to the base is always the base, perpendicular to the base. Any prism or cylinder is a rectangle, pyramid or cone is a triangle. Area on the grid, build your rectangle, find the area of the rectangle, find the area of the triangles, half length times width of the triangles, add the triangle areas, subtract them from the rectangle area. Triangle area, half A, B sine C. PD-POP, population density is population over area. Volume, build your volume formulas on your reference sheet. 3 length times width times heights. 2 pi r squared heights. 1/2 is for triangle. 1/3 pyramid and cone. Rounded, type pi in. In terms of pi or pi's in the answers, don't type pi in. Basic dimensional analysis. You know how to do that or you don't. 3D rotations, you reflect in 2 dimensions and connect with curves. Line dilations, parallel, keep the slope. The slope's always the same. If it's not the origin, it's the same line. For the origin, multiply the scale factor in the original B for the new B. Circle, negate what's in the parentheses for the center, square root of the right-hand side for the radius. If there are no parentheses, coordinates 0. If it's in standard form, use the conics app. Make sure it's equal to 0. And to get out of the conics app, second quit. Partitions, delta x over p, delta y over p. Use the attached graph paper if needed. The answer is what comes first in the ratio. For your circles, arcs and angles, 2EA, 2VA. For segments, PP, wee. E stands for exterior, so if it's something outside the circle, then it's the one with the E. If not, then it's not. Theta pi r squared over 360 for area of a sector. Theta pi d over 360 for arc length of the sector. And then again, know how to prove your different shapes with coordinate geometry. We're always calculating distance, except for trapezoid, in which case we're calculating slope. Say what they're trying to prove because, calculate your distances or your slope, and then tie it together, tell me what's congruent to what. If it's a right triangle to show if it's in Pythagorean theorem, then you're literally substituting your distances into Pythagorean theorem. You got this. You got this. Practice. If you know how to do all this, you're in good shape. Again, I would also strongly suggest you know how to do the not as commonly asked, but still commonly asked questions that aren't hard. And it would, of course, be great if you can do the commonly asked questions that are hard. I would say like and subscribe. I really don't care. Just kick butt on your exam. Kick butt in your exam and then move on with your life. Goodbye.